Hello, I'm Cindy Carlson from New England College, and this is video 6A, the first set of parameters that we'll be discussing. Today, or in this video, we'll be discussing temperature, stage, and conductivity and salinity. So first, temperature. Temperature is something that you're probably very familiar with. It can vary with season. So in the winter, it tends to be colder. In the summer, it tends to be warmer. But it can also vary with weather. Weather is a shorter term variation. So it's not always colder in the winter, and it's not always colder in the summer. But on average, over an average of, say, 10 years, it would tend to be colder in the winter than in the summer. Temperature can also vary by how much pavement is in a watershed. So watersheds that are less paved tend to be cooler. And this is because as rain falls on non-paved surfaces and runs off, the runoff would be relatively cool. Whereas when rain falls on paved surfaces, those paved surfaces have been heated up by the sun. The rain is therefore warmer as it falls on, and the runoff is relatively warm. So watersheds that have more pavement on average would be warmer. Watersheds that are very shaded, or water bodies that are very shaded, would tend to be cooler because they're in the shade. Kind of makes sense as well. And this is why water behind dams can tend to be warmer, because the dams impound the water and there's generally not as many trees and the water just sits there getting warmer and warmer. But water that's been shaded may have some little cool pockets and the water would be cooler in general. Groundwater is roughly the same temperature year-round. So in the summer, groundwater might be cooler than the water body, and therefore the groundwater that's coming into the river would tend to cool the water body down. Whereas in the winter, the groundwater might be warmer than the water body. And as the groundwater flows into the water body, it might warm it up a little bit. So watersheds and water bodies that tend to have a lot of groundwater input might be more temperate, so more moderated, not quite as warm in the summer and not quite as cool in the winter. So in general, the factors that influence temperature would be seasons and weather, the percentage of the watershed that's paved, the percentage of the water that's from groundwater, dams, and the characteristics of contributing streams. So in this figure, you can see this little stream over here that's contributing to the larger Merrimack River. This is Concord. So the contribution of this stream might influence the water downstream in the Merrimack. If that water body coming in is very urban, it's going to tend to warm up the mainstream, whereas if it's very rural or very wooded, it will tend to cool down the mainstream. And you can even see in this picture a dam here in the middle. So that might potentially change the temperature of the water body of the Merrimack. And the urban area over here as well might be warming it up, whereas the less built up area here may be cooling down the river. So both warm water and cold water fisheries are important in New Hampshire. New Hampshire actually doesn't have a temperature definition for what is meant by cold water fisheries. Here and many other places, we define cold water fisheries as fisheries that can support brook trout year-round. So streams and rivers that support brook trout year-round would be cold water fisheries. In Massachusetts, they define a cold water fishery as a fishery that has a maximum mean monthly temperature. So the average monthly temperature throughout the year is less than 20 degrees Celsius, and that's 68 degrees Fahrenheit. So you can get a rough feel for what that means. So, of course, the fish that are going to live in cold water fisheries would be brook trout. They're the definitional species. They define the cold water fisheries. But also brown trout and Atlantic salmon really also like cold water fisheries. Warm water fisheries are defined as supporting large or smallmouth bass or pickerel year-round. So again, the brook trout may live in warm water fisheries, but they just wouldn't live there year-round because it gets too warm for them. So the types of fish that live in these fisheries or rivers would be walleye, white perch, and then, of course, the smallmouth and the largemouth and the pickerel. Another parameter that we'll discuss today is stage. And stage is a term that means the level or the height of the river, the depth of the water. So after a rainfall, you've probably seen stream levels rise, and the rate of change of that rise in stream water can show you how urban the stream is. So if it's a lot of pavement, we talked about how that can impact the temperature in the water, but it can also impact the level of the water, how quickly the water rises. So as you can see at the bottom here, in the picture at the bottom, that the elevation or the depth of the water changes across the water column. So we really need to come up with a specific location that we're measuring that depth. So that's why in the picture here you see that the ruler is fixed to the rock. And we try to measure stage in a particular location so that we can see how it's changing relative to itself over time. There are seasonal differences in stage as well. Here is a graph of the Salmon River, and it shows the flow, so how much cubic feet per second are coming through that river. And the stage is going to be related to that. So how high the river is will be somewhat related to how much water is flowing through that. As you can imagine, it's rising towards the end of March and April as there's a lot of snow melt there. It's going to reach its peak somewhere in May or June, depending on the year. And then it's going to drop back down for August and September, where it's very dry. There's no snow melt coming in. The only water that's coming into the river is water that is through rainfall or groundwater. And then it might eventually start to come back up again as the spring proceeds. Another thing that impacts stage is how urban the watershed is. We talked a little bit about this. So if it's an unurbanized watershed, the rainwater that falls in the watershed might soak right into the grass, might be picked up by the trees. And it's not generally going to be running directly across the overland into the water body. It would be much more likely to percolate through the ground, through the soil, into the groundwater and come into the river like that. Whereas in urbanized areas, it's going to run right off the surface. It's not going to have a chance to be picked up by plants. It's not going to have a chance to soak into the soil. It's going to go straight in. So if we look at the two curves, the gray one is the urbanized and the green one is the unurbanized, or the rural or the forested watershed. So you can see for the same amount of time that's passed, there's a lot more water going in the urbanized watershed. And here's the peak of the urbanized watershed. The unurbanized watershed hasn't even come up to its peak yet. The urbanized watershed is now coming back down for the same amount of time passed. And here, now the unurbanized watershed is contributing more water to its water body, and then they kind of go off together like that. So you'll be able to tell something about the urbanization of the watershed by looking at how quickly the water reaches the water body after a rainfall. And the last metric that we're going to look at today is conductivity. Conductivity is the level at which a substance conducts electricity. So wires and pipes, metal conducts electricity, but water also conducts electricity. Water conducts more electricity, or we say has a higher conductivity, when it has more salts and metals or other non-organics dissolved in it, when it's warmer, and when it runs through clay soil. And it conducts less electricity or has lower conductivity when it is oilier, when it's colder, or when it runs through granite, because granite is inert. Granite doesn't like to play with others as well. So the a sewage spill into the river would raise the conductivity because sewage has those dissolved solids in it, whereas an oil spill would lower the conductivity. So we can't necessarily tell how clean the water is by looking at the conductivity, but we can tell some other things. For instance, we can tell the salinity, so how much roads have been salted recently. In New England, we certainly do like to salt our roads. That's important for safety in the winter, but it also impacts the water body and makes our rivers a little bit saltier than we would like them. And we can measure that way by looking at the conductivity. So thank you for watching this video, 6A, and now please go to the content quiz to show that you have watched the video. The quiz can be found at this address, or just click on the link at the project webpage. Thank you so much.